Alright guys, welcome to your Monday night's homework. We'll see how this goes. I think this would be a really interesting way to do class. We'll try it for a couple of weeks, see how it goes. We're just going to go through kind of a sum up of all your posters, make sure everybody's got them all, and then look what we can do with that as far as numbers go. Looking at my notebook, guys, it's about a page of notes of what I've got between examples and pictures and words. Thinking maybe 15-20 minutes tops for this video. You'll be amazed at how fast things go when we're not all interrupting each other in class with stories and making you be quiet and all that kind of stuff. For those who like your titles, we're still in Unit 3, which is angles, and we are still on Section 1, special angle pairs. The beauty of the video is that if I go too fast, you simply push pause, finish writing stuff down, you can rewind, you can watch it again. If you write really quick, you watch it once and you're done. So everybody can kind of take their own time with this. All the stuff you guys came up with on your posters are actual math rules, alright? So first thing I want to talk about is the difference in rules. We have had postulates before. And postulates are just accepted rules. So we just go with them. We don't worry if, why they're true or how they're true. They just are true. They're postulates. We accept them. Most of what we're working with now are called theorems. Kind of got the word theory out of there. It's a rule that needs proving. And you kind of prove these by example. Is what we call it when you do one or two types and you show that it's true. We will eventually prove that it is true all the time, absolutely, positively, always true. But you guys did, we call it proof by example. So we've kind of already proven some of these. First one we have is the corresponding angles postulate. Notice this one is a postulate. What does that mean again? Good. I'm glad you answered out loud. Everybody around you is looking at you funny. The corresponding angles postulate is accepted. We just go with it. It simply says, if two lines are parallel, then corresponding angles are congruent. Not real tough at all. The group that had this, oh, sorry, that made no which part. Remember, if I go too fast or whatever, just pause, rewind, write it down, and pick it back up. The idea is this: if I have a set of parallel lines. Now I know my lines are never perfectly parallel, so with the little markings on there, then you get to assume that they are. If I know this angle up here is 150 degrees, and I want to find this angle, well, lucky for us, those are corresponding, and our corresponding angles postulate tells us that corresponding angles are congruent. So if that top one is 115 degrees, the bottom one is also 115 degrees. Not too tough. What's going to be tough? Not even tough. What's going to be a little more complicated is when I don't tell you what we're looking at. In this case, I said, hey, we're looking at corresponding angles. You might get a problem and you've got to figure out which one it is. And we'll do a couple of those. Alternate interior angles theorem. Notice this one is a theorem. That means we're going to actually prove this later on. Yeah, probably by everybody's favorite two-column proof. We're going to learn something called flowchart proofs, which actually make a lot more sense than the two columns. So we'll see when we get to that part. Alternate interior angles theorem, very much similar. It simply says if two lines are parallel, then alternate interior angles are congruent. Do you know why I'm not referring to the transversal in this theorem? Why I don't need that? Take a moment, think. Why don't we need to talk about transversals in this theorem? Yeah, okay. If you remember, what's the definition of alternate interior angles? The definition of those angles includes the transversal there. So if I have alternate interior angles, I have to have transversal No need to mention it again. Why do that? Alright, same idea here. If I have my parallel lines, assume that they're parallel, right, with my little markings. If this one is 59 degrees, its alternate interior angle, which is across the alternate, also inside this one down here, is also 59 degrees. Oh, by the way, as I hear the fan on my projector going, if my projector goes out, there'll be a weird blip in the video where I have to pause it, go steal somebody else's projector on this Saturday morning, and then replace it later, maybe. Guess what? I bet we also have an alternate exterior angles theorem. And guess what? It's exactly the same. If two lines are parallel, then alternate exterior angles are congruent. By the way, so we'll see how this works. If you're watching this video, don't tell this to anybody else. But if you come in the morning before school on Tuesday and you say that Miss King is the weirdest person you've ever met, I will give you a choice of your candy from the candy bag. So we'll try this. We'll see if this sneaking this in will get you guys to watch this. So remember, Miss King is the weirdest person you've ever met on Tuesday morning, and you can get a piece of candy. In addition to learning all this new math. Yay! Picture, again, looks very similar. Parallel lines, transversal, alternate exterior. If this one over here is, say, that looks like about a 62-degree angle. Its alternate exterior angle, down and over here, is also 62 degrees. All it means is they're the same measurement. Most of this I think you guys already knew. I just want to make sure you have it in one spot and you know it's where you can always refer back to it. Almost done, just a couple more, and then we'll do a couple quick examples, and then that'll be done. How long have we been going so far? Oh, it's only been like 7 minutes. Look at how fast we get through notes this way. We have a same side interior angle theorem. THM, by the way, that abbreviation there, that's just abbreviation for theorem. I was obviously running out of room because I write really big. This one simply says if two lines are parallel. This one's slightly different, not much. Then same side interior angles are supplementary. I hope we all remember supplementary. We've done this a bunch now. Supplementary means they add up to 180 degrees. So if I look at my lovely parallel lines picture, if this angle right here is 110 degrees, first thing I do is gotta find its same side interior angle. Same side, so same side of the interior, right there. To find out that angle measure, I simply take the 110 and subtract it from 180, and I'm left with 70 degrees. Alright, so if you're solving for it supplementary, you know, you could do the work the long way. 110 degrees plus the x angle we don't know equals 180 degrees. You would subtract the 110 from both sides. X ends up equaling 70 degrees. Now eventually we'll need to do the algebra the long way because we're going to get more than just an x in that angle. But for now, all you got to do is subtract from 180. Nice and easy. The same side exterior angle theorem reads pretty much the exact same thing. If two lines are parallel, then same side exterior angles are supplementary. exact same thing as the other ones. All right, for this picture, that's a little far. I'm going to mix it up a little bit. I'm just going to turn my parallel lines sideways. Transversal going that way. There's really no difference. If you don't like looking at it this way, take your paper, turn it sideways. That's all you got to do. Right? So if I'm looking at same side exterior, this one up here may be 59 degrees. Well, it's same side, so in this case, like the top of that transversal. Exterior, so on the outside, look at this angle over here. I'm going to take 180 degrees minus 59 degrees because they're supplementary. And I in fact get, let's do this another calculator. 1, 2, 121 degrees. Not too bad. There's only one other type we did. It's a pretty easy theorem. It is in fact the vertical angles theorem. It's one of my favorites because it's actually used a lot in a lot of different ways. It simply says if two angles are vertical, then they are congruent. I just realized I can't upload over 10 minutes. That's okay. We'll find a different way. If I have to pay for a month or whatever of YouTube so I can upload more than 10 minutes of video, we'll do that. I just realized I can't do that. Darn it. Okay, anyway, vertical angles, always congruent. Always. Vertical angles are formed by two lines that cross. Alright? So if this is 110 degrees, how much is its vertical angle? Yes, exactly. Also 110 degrees. Again, I hope you answered out loud, and I hope there's something right. Alright, the other angle, if it's 70 degrees, its vertical angle, when across from it, is also 70 degrees. We've been looking at them this week in our same picture with the parallel lines, because there's lots of vertical angles going on here. Right? If this one is 60 degrees, you first got to find where is its vertical angle. Oh yeah, it's right across from it. It's right here. That one is also 60 degrees. So vertical angles are always congruent. Alright, let's look at a couple examples. I know that white's really bright. A couple examples, and then we'll be done. And then that's it. As long as you wrote this down, you know what you're doing tomorrow morning. Hint, hint, wink, wink. You should be good. Okay? So, what if I said, in this example, there's your parallel lines and your transversal. Let's say this is 112 degrees, and I said solve for x. So it's really pretty easy. The problem for you is to figure out what type of angles are those two in yellow. Are they alternate interior, alternate exterior, same side interior, same side exterior, corresponding vertical? What are they? So I look and I say, okay, well, first of all, they're definitely on opposite sides of the transversal. So that lets me know it's not same side interior, same side exterior, or corresponding. My only options are alternate interior and alternate exterior angles. Next thing I look, I say, are they on the inside of the parallel lines or the outside of the parallel lines? They are in fact on the outside. So they are ABA. Now, do I expect to see all of that written on your paper? No. Honestly, most of you can do that in your head pretty quickly and figure out what they are right away. Now that we know they're alternate exterior, you look back to your theorems, or you already have them memorized by now. You say, alternate exterior angles, they're congruent, they're equal. So x is 112 degrees. You can write it down there at the bottom. You can write it up there in the angle, wherever you want to write it, as long as it's there. That's pretty easy. Alright? Two more examples, and I'll be done. Alright, we'll do another somewhat easy one. Say this is 50 degrees. There's my angle x. Find x. So again, I think to myself, well, what kind are they? Well, I see they're on the same side of the transversal, inside the parallel lines. That makes them same side, interior angles. So again, I kind of think back to my theorems or look back at my notes and say, same side interior, or those are supplementary. See, in my brain, I think the S and the S, they match up. this from same side and this from supplementary. That's how I remember them in my mind without having to dig through everything else. So that tells me if I take 180 minus 50, I get what? Good. You probably got that before me. 130 degrees. And that's what that angle is. It's about as complicated as we're going to get for now. We'll eventually throw some more algebra in. We'll throw in some more complicated looking shapes, pictures, I guess. But we're not going to get terribly worse than this for the next couple days. Alright, if you need to replay the video is yours. You can rewatch it before the quiz. You can watch it before the semester exam. If you have nothing else to do over the summer, you could rewatch it then for fun. But for now, it's just here for you for tomorrow.